Good evening, Dr. Joanna and everyone. We are Group 10 from the course of Fluid Mechanics Laboratory. This time we are conducting the experiment Bourdon tube pressure gauge. My name is Yee Wei. Our group leader is Syahidah. Sree, Pik Lin, and me are group member of Group 10. This is the table of contents. Now we start from the report summary. The apparatus that was used in the experiments are Bourdon tube pressure gauge, Pik Wei tester, and the 1 kilogram pistons. The gauge pressure in this experiment is conducted by increasing and decreasing the dig weight. During the experiment, the air bubble must be removed from the cylinder by rotating the piston slowly to get the accurate result. However, there is a percentage error in these experiments, which means that the experiment data is affected by the theoretical values as there were some error happened during the experiments. The percentage of the relative error for the theoretical pressure and the experimental gauge pressure can be compared from the result, and then the accuracy of Bourdon tube pressure gauge can be determined. The objective of the experiment is to calibrate a Bourdon tube pressure gauge using dig weight. In order to calibrate the gauge pressure, we also need to find the percentage of error. In introductions, one of the basic processes used to keep the accuracy of an instrument is instrument calibration. It is the technique of configuring an instrument to provide result within an appropriate range. To obtain the accuracy of reading from the pressure gauge, some weight were added to a dead weight tester to apply pressure to fluid. In these experiments, Bourdon tube pressure gauge is used as the pressure measuring instrument. When pressure is applied to the tubes, it begins to strengthen out. Besides that, the deflections from the ends of the tubes to a recording point is transmitted through a system of lever. The pressure shows the difference between the system pressure and to the external pressure and is normally referred to as the gauge pressure. Another calibration device that is used in our experiment is the weight tester. Next, we want to move to the second part, which is about the theory. Bourdon tube pressure gauge is a mechanical device used to measure and display the pressure. The gauge can be used for measuring pressure in both gas and liquids. This picture is show the Bourdon tube pressure gauge. A Bourdon tube obeys Hooke's law that is within elastic limits. Its free ends will experience a movement that is proportional to the fluid pressure applied. The Bourdon tube pressure gauge consists of a circular tube which is bent over an angle of generally 270 degrees. The tube is sealed at one end, that is the tip, and connected to the pressure at the another end, which is socket. Any pressure inside the tube exceeding the pressure on the outside will cause the tube become more circular in cross sections. As a result, the tip moved and arc. The amount of movement of the free ends of the tube is directly proportional to the pressure applied. Spiral or helical Bourdon tube was used when greater sensitivity is needed. Then this picture is show the dead weight tester. As we know, a dead weight tester is used to calibrate the pressure by determining the weight of force divided by the area the force is applied. Dead weight testers are used to measure the pressure exerted by the gas or liquid, and it also can generate a test pressure for the calibrations of numerous pressure instruments. The formula to design a dead weight tester is pressure equal to the force divided by the area, and the force is mass times the acceleration due to gravity. In dead weight tester, we put the weights on the weight stands of dead weight tester. Putting weight is a reference weight which is to be calibrated, and further we apply pressure by moving pistons. When applying pressure and reference weight is equal at these conditions, reference weight will be zero, therefore it's called a dead weight tester. That's all my part. Then I will pass to the Pik Lin.
Hi, my name is Pik Lin, so I will be presenting the methodology. So this is the apparatus that we use for this experiment. We actually use the Bourdon tube pressure gauge, dead weight tester, and also one catchy piston in this experiment. This is the procedure. So first, the cross-section area and the total mass of this piston were recorded, and the cylinder connected to the hose was filled up with oil. And the piston will be inserted slowly into the cylinder and the air bubble was removed from the cylinder by rotating the piston slowly. The gauge reading due to piston weight 1 kg was also taken as the first reading, and the load weight of an increment of 0.5 kg was added slowly to the piston, and the pressure reading was taken at this moment. And step 3 and also step 4 was repeated until 6.0 kg for each 0.5 kg increment. And after the maximum pressure reading was obtained at 6.0 kg, the weight are unloaded from the piston by the same increment and the pressure is recorded also. And lastly, the experiment is repeated for 3 times to get the average value.
Hi, right now I will discuss about the result and discussion. Okay, so this is our table. It consists of mass, which is in kilogram. The total mass added, which is the increment is 0.5, and then there is actual pressure, which is in kilopascal, and gauge pressure, which is consists of loading and unloading. In this experiment, we do about 3 times, and then we will find the average. And the last one is the percentage of error for loading and unloading. Okay, next for the discussion. First, the percentage of relative error for the theoretical and measured experimental pressure gauge. Okay, for the method of calculation, first, the mass of piston given is 1 kilogram, and the cross-sectional area of the piston is 3.1731 times 10 to the power of 4 meters squared, and the acceleration due to gravity is 9.81 meter per second squared. And then we will find the true pressure exerted by piston, which is mass of piston times of the gravity and divide by the cross-sectional area of piston, and we will got the answer is 30.9 kilonewton per meter squared. And then for the true pressure exerted by total mass, the result is equal to 46.4 kilonewton per meter squared. And then we will find the average reading of calibrated pressure. The final answer is 30.3 kilonewton per meter squared. After that, in order to find the percentage error for loading, the formula is measured value minus with actual value divide by actual value and times with 100. And the answer is 34.7% for loading. And for the percentage error for unloading, is equal to 13%. That's all from me. Thank you.
Okay, today I'm going to explain about the discussions of sources of error and method to minimize the errors. So, based from this experiment results, there were several errors affecting the outcome of the experiment, since there was a slight difference in the reading between the calibrated pressure and the theoretical pressure. First and foremost, parallax error might occur because the observer's eyes are not aligned with the scale of the Bourdon gauge. Next, there are air bubbles trapped inside the tube when conducting the experiment. Besides that, the dead weight gauge calibrator might work slowly in changing pressure and cause friction to occur. In addition, the piston might not be in stable condition during calibration of gauge pressure and might cause leakage. However, there are some methods to avoid or minimize these errors. To prevent parallax error, the observer's eyes should be parallel to the pointer and scale when taking the readings. Next, we also should give enough time for all trapped air bubbles leave from the cylinder and hose. In addition, to avoid friction, the weight is loaded slowly. Besides that, the piston is also placed gently to avoid excess pressure which causes friction. Next, now we're going to see repeatability and accuracy of this equipment. Repeatability in the world of Bourdon tube pressure gauges means the essential the same thing. It means within the realm of flow meters or other measurement devices. Accuracy is same as the repeatability equally and independently important in determining the quality of a Bourdon tube pressure gauge. It is a measure of how consistently the pressure gauge is inaccurately repeating the same measurement if all conditions remain the same. Accuracy is a measure of how effectively the pressure gauge is in repeating the upscale reading on the downscale cycle if all conditions remain the same. For example, if exposed to the same pressure on two separate occasions, the gauge would show the same PSI if all other ambient factors such as pressure and temperature remain the same. For example, while a pressure gauge may read correctly at zero, midpoint, and full scale during the pressure up cycle, it may read too high at the midpoint check during the pressure down cycle, while still correctly returning to zero. Thank you.
Okay, so it's me again. So I will be concluding everything in this experiment. So the Bourdon gauge is the popular pressure measuring device for fluids such as liquid and also gases. It also can be connected to a pipe or vessel that contain liquid or gases that is pressurized. So in conclusion, the objective of this experiment is actually achieved, which is to calibrate a Bourdon tube pressure gauge using that weight. The Bourdon gauge is normally used to measure the gauge pressure, which is pressure difference between the pressure in a device with the atmospheric pressure. The gauge pressure in this experiment is measured by adjusting the weight of the dead weight, and then the experimental value of this experiment, okay, for the measured pressure is actually used to compare with the theoretical value by using the formula given and the result that we obtained in this experiment. So the dead weight with a mass of 0.5 kg is used and slowly added at the weight to calibrate the Bourdon tube to measure the pressure until 6.0 kg. It can be concluded that the experimental pressure obtained in this experiment is higher than that of the theoretical pressure. Besides, some error might also occur during this experiment, and it will be affecting the outcome of this experiment, such as the pressure that we obtain. However, there are methods that can be used to avoid or minimize the error, such as to align the eye level while reading the value from the Bourdon gauge, giving enough time to allow the air bubble to escape and the load slowly to avoid friction, and place the piston gently to avoid excess pressure which will cause friction. So that's all from me. Thank you. This is the reference that we use.